Okay, yeah, there's a way to actually put the length in it, but I think it's just the first byte which is specific, which says, you know, this is the start of a SysX message, that's the vendor ID, and that's the end of a SysX message, and what's in between is actually whatever you want. So on the MIDI side, that was what the protocol looks like. When you're programming, you only need to know it if you do like the lowest level of it. And I've provided some libraries to do it, so you don't have to worry about that. But it's still very interesting to know how it looks like. And in a MIDI studio, like an electronic music studio, you usually have three kinds of devices. The first kind of device is mostly receiving data, and that's synthesizer. So they just receive, for example, play this note, and the synthesizer will play the note. Then you have devices mostly sending data, which is sequencers, which play back MIDI information, and MIDI controls, which are just used to control other parameters of MIDI devices. And what our hacking is going to concentrate on is mostly on sequencers and MIDI controllers, which is because we can produce sound on it. So yeah, there's different ways to connect MIDI to a computer. If you remember the old sound cards, they all had this joystick port to which you could plug in a MIDI cable. Nowadays, it's mostly FireWire devices and USB MIDI devices. So my devices have USB, and you plug it in, and it appears as a MIDI device over USB, and you can use that to send information or to reprogram it. And the MIDI bus can be changed to serial bus, and on most devices you have one input port, one output port, and a through port, and this one port just electrically mirrors the input port, so you can chain multiple synthesizers and have them all respond on the same data that's sent in. And if you want to do more complicated stuff, which actually is pretty almost always, you have to use custom MIDI hubs and MIDI mergers. If you want to synchronize some device of a friend and you want to send clock to it, then the nightmare starts, and it's like drawing network topologies when you're setting up a network, you know, at a LAN party. The device I built is based on a NatMel microcontroller, and what I did in the last few days is actually integrate it with the Arduino environment. So I don't know how much of you have heard of Arduino. That's nice. So what I basically did is add a menu to Arduino to program the microcontroller over MIDI. So you have one menu where you can select the MIDI device. And I wrote a lot of libraries you can use in Arduino to send MIDI messages, to receive MIDI messages, to synchronize to a clock. Some weird sequencer ideas I also built, and some stuff to parse SysX, to encode SysX. And so a lot of the quite complicated sometimes functionality has been integrated for easy use. Like one of the most difficult things to build was besides the USB MIDI stack was to build synchronization, to have a tight synchronization to an external device, or to be able to send clock that is tight. That was quite tricky. And if you want some hairy technical details, you can come to the workshop tomorrow. But mostly, if you just want to try out some easy ideas, you can just fire up Arduino and write a few lines. And most of the examples I'm going to show now are based on this. So it's based on an Atmel CPU, and the libraries I've written in assembler, which is all for the Voodoo time-critical stuff, which is parsing all the knobs and buttons and using the display, and also for MIDI clock. And the rest is written in C and C++. So on the Arduino side, you just have your C++ objects, and it's all pretty easy. So what this really changed for me is, before, I mean, I've been writing firmwares for microcontrollers for a few years, but always when I wanted to try out some stuff, like for example, you could just use that button to do this thing, it will involve making a new directory, copying all my libraries into it, and make a make file and writing a new main function. So that really slowed me down, because I would just say, let's do it tomorrow. And what I can do now is, if I have just an idea, just like press Apple N, write a few lines and upload it, and that really changed the way in the last 2 weeks, I just wrote so much more firmware than I ever did before. And it's much more exploratory. So I don't know if you've been using processing as well. You know the feeling when it's just like easy and it works, and you just try out some stuff. So yeah, I'm really excited about this actually. And the cool thing about it is if once it's written, you just plug it in and it works, and you don't need to set up some software which does some kind of merging, which is going to crash. And also, if you don't want to use a computer to do music, you can actually pull all the algorithms you have in, for example, stuff like Max MSP or so, and just put it into hardware. So Max MSP is some kind of weird signal programming program which you can do some weird stuff with. Yeah, and I tried out a lot of crazy ideas, mostly randomizing parameters. So it's always very nice to have a synthesizer patch and just press random, and yeah, that's nice. It sounds nice, and store it. I built a lot of sequencers and also cool tricks to interface with hardware. Like for example, when I wanted to access the delay on my synthesizer. So I'm going to show you a few of those things I built, and yeah, in the last few days. So are there some questions before I move over to the examples? Are there some questions about MIDI or microcontroller programming? None, so I'll move on. Yeah, one of the most obvious features you can do is actually just change the behavior and the layout of your MIDI controller. So if you want to have this note on this knob or this one on this one, you can do it pretty easily. And you can implement custom features for your software or synthesizer. For example, one of the things you can do with the machine drum is, I'm just going to load a patch and show you what I mean, is it's mostly a drum synthesizer, so you mostly have sounds that sounds like this. And what you can do with it is actually pitch the sounds so they sound like notes. So that's, for example, a snare drum. And what I can do is, so the idea was to actually convert a note I play on the keyboard to a pitch message value, which is going to be something like 81 is a C, and 85 is a D, and 87 is an E, and program it into this device and just hook up a keyboard to it and play the drum machine as a synthesizer. So that was actually pretty easy to program, and I'm going to show you an example of that later on. I did the same with a machine called the Mono Machine, where it was lacking a few features I really needed, and a lot of people actually wanted to have, and was able to program them just in a, because it's actually pretty easy code. It's just like, oh, if I receive this byte, I'm just going to send these 2 bytes. And there's no way to do it usually. So another thing I did is the program called Ableton Live. I don't know if you've heard of it. It's one of a program to make and play electronic music on a computer. You can actually load scripts into it and access the internal information of the music that is running. And I use that information, sending it back to a MIDI control to actually display clip names and display some information, and also to randomize the setup of your music piece. So it was pretty fun as well, and it's always like kind of going into the back door and trying out stuff like you would do in software hacking. So yeah, that's the example I showed. Just use the pitch of percussion machines to play notes on the drum machine. So you can actually use a hi-hat and play it as some kind of bell, or the snare drum, which normally sounds kind of like this. So you can change it to have something like this. On the Mono Machine, I had, yeah, one of the really cool things about this is that you can randomize sounds in a kind of intelligent manner using genetic algorithms, for example, or using interpolation to discover new sounds you'd never come up with by hand. So for example, I can store like a parent sound and a mother sound and then merge them and try out some new variations. So it's pretty funny as well. It's what we did all night yesterday. So I'm just going to skip this. One of the controls I built for the mono machine has a joystick in, and you can control all the sound parameters at once with this one joystick, for example, or randomize just whirling the joystick around. And this was the Ableton Live API, which is written in Python, and I spent a lot of time hacking into it and looking how it works. So if you're interested in that, you can also come tomorrow, and I'll show you the programs. But let's get to some use cases, what it actually looks like and how it feels to use them. So this is the simplest program you can actually write on this one. It's just sending a note if you press a button. So I have a setup function and a loop function, which are not used in this exact example. And the handle GUI function is used to handle all the stuff that's buttons and encoders and stuff. So if the first button is pressed, I'm just going to send out a random note. And that's all you have to write, and then you can upload it on a device connected to a synthesizer and just press random notes. So it's kind of a stupid program, but it's fun in itself. So now the algorithmic stuff starts. For example, I want to take that random pitch and map it to a minor scale. So I've written this tool called Scale Pitch, which is just going to take a random note and scale it to a C minor scale. So that already sounds much more interesting, for example. And the program I'm going to show you now, it's called Random Notes Test. And it's the same concept than what I showed before, but this time I'm going to produce some pitch information for the drum machine. So I have this snare drum. I took my frequency analyzer and then input every value for the pitch and just wrote down what kind of frequency it was and then mapped it to notes. And then I built a lookup table to produce the correct pitch for each kind of sound you have. So that's the lookup table for the snare drum. So if you want to play a chromatic scale, it's just those values you have to input, and all the microcontroller is going to do is look up the correct pitch information for a note and send it over to the drum machine. That's the setup function of this sketch, where I just tell the library that a snare drum is loaded on those first 4 tracks here. So that's the snare drums, and I put some delay on it so it sounds cool. Delay and reverb is always the way to make good synthesizer demos. So I just tell the library which kind of sound is loaded on each track. And that's the function now. So I have 4 buttons, and if one of the buttons is pressed, I'm just going to send a note on. And this function in the machine drum library is just going to convert the pitch of the note into a pitch for the machine drum. So what it sounds like, and if it should be working correctly, is if I press the buttons on my board here, it's just going to play some random notes on the snare drum. And then you can start to change the sounds of the machines. So it's actually good fun to just sit in front of the device and go. And it's all just those random minor scale notes, so you can come up with some nice chord melodies or just have fun with it, or record it and then take out some good things. So yeah, with 4 lines of code you have a lot of fun. And you can just unplug the device from the computer and use it later on, so it's pretty nice to go away from the computer into the studio and then just try out the new tools you programmed. I'm now going to go into a bit of mathematics, and a few months ago I discovered this paper by Godfrey Toussaint, which is a musician and mathematic researcher in Canada. And he wrote this really nice paper where he shows that the Euclidean algorithm to find the biggest common divisor between 2 numbers can actually be used to generate most of African and Western rhythms. So the paper is actually about rhythms, but it starts with, I think, timing system and neutron accelerators, which is actually built on the same